Okay, we started something new today. We started looking at how to graph the sine wave and the cosine wave. And here's the big takeaways you want to get from this. One, you want to get comfortable with how this parent graph looks for sine, that it starts out as a small hill and ends as a small valley, whereas the cosine wave is one big valley. Okay, unless there are flips, then these things go different directions. The other big takeaway is you want to make sure that you memorize that the sine wave crosses the midline at the beginning, middle, and end, and the cosine wave crosses at the 1/4 and 3/4 mark through the period. Okay, you'll notice on these problems they specify whether you should be doing them in degrees or in radians. And a question that you guys were wanting me to talk through was letter B. Okay, one very important piece to this is when you are graphing these, you need to have what we call the 5 critical values labeled along the x-axis. And depending on whether your problem is in degrees or radians, you will either use these 5 numbers here, or you will use these 5 radian values here. Okay, so let's start with letter B. Okay, this specifically asked you to graph this in radians, so I'm going to go ahead and label my x-axis with these 5 critical values, which are nothing more than the radian versions of the degree measurements 0, 90, 180, 270, 360. Okay, the next thing we're going to do is we're going to look at the equation, and we're going to see if we can fill in these 3 blanks that we have here. Okay. The first question is, where is the midline located? That always comes from the number all the way on the end that you've either added or subtracted. So in this problem, the midline will be placed at 1. So if you like, you could go ahead right now, mark up to 1 on the y-axis, and put a dotted horizontal line there to represent that the midline is now shifted up 1 unit. Okay. The next thing is to identify the amplitude. The amplitude, be careful about this, it's the number that you're multiplying in front of the trig function. However, if that number is negative, you are not to report the negative aspect when you say the amplitude. You should just write down that the amplitude is 3, and if that happened to be negative, then you're going to respond on this blank that yes, this wave is flipped. That means it's going to flip in its opposite direction. Now see which wave we have here. This is the cosine wave. So we set up here the parent wave normally starts up, dips down as one big valley, and then ends back up again. Since this one is flipped, it's going to start down, go up as one big hill, and end down. Okay? All right, so what I would suggest you do next, once you have your midline in place, is look at what your amplitude is. The amplitude is how much you're going to stretch above the midline and then below the midline. So if the midline is at 1, then you need to mark off and label enough values so that you could stretch 3 more values above the midline as well as 3 more values below the midline. Okay, so if I'm at 1 here, stretching up 3 would take me up to 4, and stretching down 3 would take me down to -2. Okay, now everything is kind of labeled and in place, so I can actually start to graph this. Okay, once again, always pay attention to which wave you are graphing. This is the cosine wave, and so I'm going to take you back to the big takeaways I had here at the beginning. We said the cosine wave always crosses the midline at the 1/4 and 3/4 mark. So you're going to look at your 5 critical values. 1/4 the way through this cycle is at pi/2. So I'm going to place on the midline a point there, and I'm also going to place a point on the midline at the 3/4 mark, which is at the 3 pi/2 mark. I know that the cosine wave is definitely crossing the midline in those 2 locations. Okay, now here's what's tricky about this problem. Because we said that this cosine wave is flipped, instead of at the beginning, which is at 0 radians, instead of starting up here at 4, you're going to start in the opposite direction. You're going to go down here at -2. Okay, you are stretching whatever the amplitude is. So stretch down to -2. In the middle, which is where we would normally have stretched down, we're going to now stretch up. And at the end, we normally would have stretched up, so then we're going to stretch down. Okay, and how much you stretch is what your amplitude is. You're counting 3 units from the midline. And you can tell when you look at this graph, see how instead of it being one big valley, it's actually one big hill, and that's because it was reflected and flipped across the midline. Okay, hopefully that is enough of a push, because I know that some of you are wanting help with example C. I will tell you this is the other radian problem, so you should label it these same exact 5 critical values. You will notice this is also a flipped problem. However, it is a sine wave problem. That means when you go to graph this, instead of going up as a small hill and down as a small valley, it will be flipped the other direction. Okay. The big one that you guys had questions on was number 2. And fortunately for number 2, this was a degree problem, but you'll notice that the directions wanted you to graph 2 cycles through this wave instead of 1. So typically where we begin is we label our x-axis. And we know if we were just going to graph 1 cycle, and I'm doing this in degrees because you can see up above that that's what this problem is requesting, normally we would stop when we get to 360 degrees, okay? But I need to go 1 more cycle past that, okay? Which means I'm needing to go another 360 degrees, okay? So you can see here for right now, and this is going to change with the next lesson, but right now each marking is another 90 degrees, okay? There's like 90 degrees in between here. So I'm just going to keep adding 90 degrees, okay, until I get to 720, because 720 would be doing 360 twice, okay? So it looks like if I keep adding 90, these are the numbers that I'm going to come across here until I get to 720. Everybody see why I'm stopping at 720? Because from 360 to 720 is another 360 degrees, okay? So now I've got my x-axis labeled. I'm going to go ahead and see if I can dissect a little bit about this equation to fill in some of my blanks up here. Okay, the midline should be at 2.5. Okay, I'm going to go ahead and place that. So we're just going to kind of roughly eyeball here that the midline would fall right in the middle about there. Okay. The amplitude is the number in front of the cosine, that's 5. And because that 5 is not negative, this particular wave is not flipped from the original shape of the cosine wave. Okay. Now, when we go to graph this, and right now, let's just focus between 0 and 360. Okay, we'll do the next cycle in just a second here. Okay, since this is the cosine wave, we know that the cosine wave is supposed to cross the midline at the 1/4 and 3/4 mark. Okay, so I'm going to put a point on the midline above 90 and above 270 because that's 1/4 and 3/4 the way through the period. Okay, now when I put these other values in, and again, I'm just going to draw a small graph right over here to the side. This is the shape of how the parent cosine wave looks. At the beginning of the period, which is right here above 0 degrees, you want to stretch, but we have to stretch up 5 units. I probably should have gotten that labeled nicer. Oh my, I'm going to have to really stretch up. I'm going to extend this up. I need to be able to stretch up 5 units from this midline that's at 2.5. That means that's going to take me all the way up to probably 7.5. Okay, and then I need to have enough marked here so that I feel like I could go down 5 from 2.5. Okay, so I'm going to stretch at the beginning. I'm going to go up 5.5 units, but I'm starting at 2.5. So I'm going to go 3.5, 4.5, 5.5, 6.5, 7.5. And then in the middle, now my pencil's right above 180 here, I'm going to be counting down 5 units. Okay, okay? So if I'm at 2.5, I'm going to go 1.5, a half, negative 1/2, negative 1.5, right here, negative 2.5. I'm just going to get rid of this extra thing I put here so that's not confusing, okay? And at the end of this, at 360, I'm counting back up 5 units again. Now, if it just asked me to sketch one cycle through this, I would stop right there, okay? Most of my work is done for me. If I'm going to do one more cycle through this wave, I need to make sure, and once again, keep in mind, now the beginning of this cycle is at 360, the end is at 720. I know the cosine wave is supposed to cross the midline at the 1/4 and 3/4 mark, so that means above 450 degrees and 630 degrees is the two places that I would want to place on the midline where I know it's going to cross. Okay, now the unique thing about this is right above 360. 360 is unique because it represents where the first wave stops, but it also represents where the second wave starts. So I already have that point in place as the beginning of my second cycle, but when I'm working through here above 540, I'm going to need to go down to that negative 2.5, and then at 720 at the end, I'm going to go back up to 7.5. Okay, and then I'm just going to connect these, and you can see that this is 2 periods or 2 cycles through the cosine wave. Okay, if you have further questions that I did not answer, please let me know. One slight push for anyone who needs it on letter D is that your amplitude is a half. That means you're only going to count half of a unit above the midline and half of a unit below the midline when you're placing those points.